All right, so I'm just going to kick us off with a very quick introduction to some of the motivation and aims for the deep crustal seismic lines. So I joined GSWA in 2012, having come from academia, and one of my nagging concerns when I took the job was having to work only on Western Australian geology. Well, it didn't take me long to realize that this was not something that I needed to worry about. WA has incredible geology, spanning nearly 4 billion years of Earth's history, with a wealth of mineral and energy resources beneath our feet. And nothing exemplifies this better, I would say, than the Yilgarn Craton and its margins, which we have the pleasure to showcase to you today. So GSWA's work in the West Yilgarn, we started a program of more detailed 1 to 100,000 scale mapping west of the Ida Fault in about the year 2000 with the Central Yilgarn Mapping Project. And this really was in the last days of kind of old school geological mapping before the use of digital field tablets, very limited geophysics, and hardly any geochronology. But we produced a number of fantastic map sheets nonetheless, shown there in blue. We then moved westward to the Murchison region. By this time, we did have detailed geophysics, and geochronology was business as usual for GSWA. And the work from this program established the stratigraphic framework that we largely continue to use today. We then moved a little bit to the south, to the Yalgoo region, where we defined the older stratigraphy and provided the geological context for gold and VMS mineralization in the region. And then by 2021, we were largely focused in the Southwest Yilgarn. And this was partly a response to the travel and operational restrictions during the COVID pandemic, during what we called the Accelerated Geoscience Program. So the purpose of the AGP was to produce new data sets and information using our legacy samples and existing data in key regions. And this was very much largely focused on the Yilgarn Craton. We produced a number of interactive and spatial data sets that we compiled into 3 different geological exploration packages, one of which was the Southwest Yilgarn, and that's all available on the ebook shop. And some of the significant results of that compilation was an updated interpreted bedrock geology map, which is shown here on the right. There's also a huge poster of it back there, as well as a revised terrain boundary between the Southwest and the UNME terrains. So these were significant improvements to the previous work that we had done, and this region hadn't really been mapped in detail since the early 1990s. So these were great, tremendous improvements to our geological understanding. So data acquisition in the Southwest Yilgarn really went to the next level with the deployment of WA Array in late 2022, with the results released last year. And the location of phase 1, which is shown here in the green circles, served 2 important purposes. 1, it was in an area where we were actively working. But 2, it was also close to Perth, which was really handy for the logistics support when we were kind of getting our feet wet with this very, very ambitious program. So WA Array, along with WAMT, which as I've mentioned, we're going to see the first results from today, are providing cutting-edge geophysical data sets that are allowing us to really understand the 3D architecture from the very uppermost surface all the way through the lithosphere. So these are incredibly powerful data sets that when we integrate with our other data sets from our project work focused in the West Yilgarn, we suddenly have an incredible data set to work with to really get into the guts of our geological questions. So about the same time that WA Array was kicking off in 2022, we started the planning for the acquisition of the seismic lines we're talking about today. And that includes the Southwest line, and 2 in the Midwest. And this really does reflect the progression of our work westward to the Yilgarn, to the West Yilgarn and its margin. There's a lot of good reasons for us to be working here. Firstly, it's great geology. There are several geological questions to resolve, some of which we'll touch on today, but I wouldn't be surprised if we've got more questions than we do answers at this point. But great geology to look at. The region is also incredibly prospective for a range of energy and mineral resources. So this map here shows the occurrences of operating mines. This will come through in many of the talks today as well. The recent discovery of Julimar, a major PGE nickel copper deposit as recently as 2020, is a fantastic reminder that there are still major discoveries to be made so close to home. This is obviously also our major population center, and so we have competing land use in this region. So having the data sets and the information to make the most informed land use decisions in this area is absolutely critical. And lastly, related, it's close to infrastructure, which is really handy for project development, and this is particularly relevant when you're thinking of the burgeoning carbon capture and storage projects that are hoping to kick off in the Perth Basin. So our work in this area, our detailed work in this area, is long overdue. So in late 2023, we started the acquisition of nearly 1,200 kilometers of active seismic data along these three lines. Data acquisition was completed in February 2024, and the work was done by HiSeis, who I believe is in the audience today. This work was funded from the Exploration Incentive Scheme, as is much of the work that we'll be talking about today, and we acknowledge the support of the state government as well. And yeah, we're incredibly lucky to have this program. Survey configuration is shown here. I'm not going to talk to that, but there are several people here that would be more than happy to step you through all these details throughout the day. So in terms of aims and motivations, as with any deep crustal seismic line, what we were really aiming for was to get an understanding of the deep crustal architecture and how units are behaving at depth and how they fit together. And these particular lines were designed to cross a number of the tectonic units in this area. And so this, going from west to east, this includes the inliers of the Proterozoic Pinjarra origin, which are shown on the map in kind of these little pink blobs. We then cross into the Perth Basin and then into the Yilgarn Craton. And in the case of the southwest line, we're going through two different terrains, the southwest terrain and the you and me. We're also, by design, crossing major crustal boundaries, so we can really start to see what the architecture of those looks like at depth. And that includes the bounding structures of the Perth Basin and the Proterozoic inliers. It includes the structures within the Perth Basin. In the case of the southwest line, we cross the terrain boundary, which we know very little about, or knew very little about before these seismic lines, and some of the major shear zones within the Archean Yilgarn Craton. We also get a fantastic view of Archean geodynamics by this line. So we've got one of the best preserved Archean cratons in the world that we're able to image. And so a lot of two out of three of the lines actually join up with existing seismic lines that have already been interpreted. So we now get a continuous view from the guts of an Archean craton all the way through to its margins. It's a fantastic data set to have. And we also get new insights into the lower and mid crust of an Archean craton. Some of it's exposed, such as what we see in the southwest line when we cross the granulite facies mid-crustal exposure of the Korhogen tectonic zone, which Raf will talk more about today. But we also see some of the unexposed units and start to really get a sense of their characters and geometries. And then we also get a view, obviously, of the modifications of the craton margins, which is really important when we're thinking about mineral systems in particular. And so this craton has been obviously very impacted during the Proterozoic and Phanerozoic, and we can start to put that history together. And these are all important components when we start thinking about mineral and energy system frameworks. So again, fantastic data to have that when we put together with the 3D data we're getting from WA Array, you will see today this is a very powerful data set. Okay, so what you hear today is not the end of the story. Our work in this region is going to continue and be refined. So we are about to release the GSWA 5-year Geoscience plan. And part of that includes more AGP style work where we're really focusing our data sets and our expertise in key areas. And part of the motivation of this science plan is to provide you with amazing data sets, but also to start trying to address some important scientific questions. Our people are scientists. We're thinking about these things all the time. We want to be able to deliver some of those results to you. And one example of a science question that we will be working on and that this data talks to is what are the key structural and compositional differences within and between Archean and Proterozoic lithosphere? So we're really excited to start chipping away at some of these things and provide you with some of this information. As part of this, we will be releasing more timely industry-ready data sets, as well as broader syntheses that will come out maybe less frequently, but are really starting to talk to these science questions. And obviously, making best advantage of the incredible data that's coming out of WA Array and WAMT is an important part of this. We want to be the ones really starting to look at some of these data sets. So this map here shows where we have WA Array data, or where we've collected WA Array data. So this is really a guide as to where we're going to be focusing our work over the next few years, and we'll be very excited to share those results with you as they become available. Okay, so without further ado, I'm very excited to hand over to our incredible speakers. So the way we've designed these talks in the morning is we're going to start with kind of the Meso Neo-Archean history that's preserved in the Midwest 2 line, or Midwest 1 line, and gradually take you closer and closer to the present. And then we've got some fantastic talks after morning tea, touching on kind of the bigger data sets we're collecting in the region. So it is my absolute pleasure to introduce our next speaker, Tim Ivanich, who will be talking on the Midwest 1 line.